Hi everyone, I'm Mike LePage, and this is the next in a series of videos I'm doing for my company Exeter Space Systems. In this one, episode 3 of my Starship design speculation videos, I'm going to talk about SpaceX's Starship and their plans for point-to-point transport around Earth. Before we get started, I want to send out a massive thank you to all the patrons who jumped on our Patreon campaign right after that second episode. The rapid progress by SpaceX since then, and the amazing animations that have been generated by people all around the world, has really made me reevaluate how I can use my style of minimum viable animation, as I call it, to show you new concepts and start new discussions. Problem with that, of course, is that these videos, and this one in particular, take me many months to create, and that isn't the regular content that fits well with Patreon. So what I'm going to do from now on is have a PayPal Pay Me link, and if you like watching ad-free videos like this one, and you'd like to support a West Australian startup company, then I invite you to donate whatever you think this video is worth. Also, if you're in the space industry and you've sent a payload to the International Space Station or elsewhere in space, then we'd really appreciate you filling out our Space Payload User Survey, the link to which I'll put in the show notes. It was in Adelaide at the International Astronautical Congress in 2017 that Elon Musk first showed us this video of Starship point-to-point transport. How amazing is it that this rocket is nearly ready for orbital tests? There are many who have written very eloquently about what a game changer this is going to be, but what I find really interesting is the logistical puzzle that this spacecraft presents. In the course of doing this project, I've come to think that whether SpaceX succeeds at operating a point-to-point service will depend on how well they balance these three factors: safety, cost, and context. I found it useful to go back and look at the early US passenger aviation numbers, which are actually quite comparable to where we find ourselves in space travel now. SpaceX's Dragon 2 capsule has a rated loss of crew risk of just under 1 in 300, whereas getting on a plane in the late 1920s was also a risk of death of just over 1 in 300. Fast forward 10 years, and the DC-3 lowered that risk from 1 in 300 to 1 in 3,000. If Starship is to be the DC-3 of the space age, it seems to me that it has to aim for at least 1 in 3,000 and get better from there. Surely it should be safer than recreational sports like base jumping. To do this, of course, it must first do well over 100 successful cargo flights. One of my favorite things about doing these videos is the contributions I've received freely from engineers all over the world. Matt Lissou's paper and spreadsheet calculator was really helpful to me because it showed a method for taking assumptions you might make, like how much does a Raptor engine cost, or the number of flights over which you can amortize the cost of a Starship airframe, and use all those numbers to work out an estimated day of launch cost. The reason this was useful was because when you see how those assumptions feed into the day of launch cost, it becomes obvious that if SpaceX does succeed in mass producing Raptor engines or mass producing Starship airframes, then the cost can quickly come down to around $5 million a launch or perhaps even lower. This is the range in which I think cargo transport starts to get really interesting as an option for point-to-point transport. Just looking at rough shipping costs for sending a parcel a distance of over 10,000 kilometers. If you send that by sea, you're paying about half a dollar a kilogram and it will arrive in 2 to 3 weeks. If you go by air freight, you can expect it to cost 10 times as much, but it will also arrive in 1/10 of the time. So what about a third tier, space transport, in which it costs over $50 a kilogram, but you can rely on it arriving in a matter of hours? That's what the architecture in this video is aiming to do. And the key takeaway that I got from this section is that these launch prices are plausible, but only if you can transport 100 tons or more of cargo with each flight. So that then begs the question, for what kind of cargo will this be financially viable? After all, the Starship's payload bay is so large and its reusability makes its capacity so vast that even the global space industry's 400 tons a year of payload can be launched in just 3 flights. The 12,000 strong Starlink constellation only needs a little over 100 flights. Currently, the plan seems to be to use Starlink revenue to fund SpaceX's ambitions to go to Mars, running Starship at a loss. But I actually don't think it needs to be this way. I think Starship can pay for itself from very early on by fulfilling an unmet need in global supply chains: fast commodity transport. They will need to be innovative in how they address the environmental and noise constraints for what will be the largest and most frequently launched rocket in history. But, as I hope to show you, I think we can take advantage of the asymmetry between launch and landing to make this work. When I first started working on this project, I was sure that single-stage Starship, so Starship without the Super Heavy booster, was going to have a major role in point-to-point transport. One video I found incredibly inspiring was this one by NASA Spaceflight Forum user OneSpeed, showing a 9-engine Starship performing a skip-glide maneuver so as to achieve a range of 10,000 kilometers, or a quarter of the way around the world. Musk tweeted in agreement that yes, this was technically possible, but it's when I started looking at the economics that I found it hard to make it stack up. You still have 40% of the cost of a full stack launch, but with only 10 tons of payload instead of 100 tons. It gets even harder to imagine if you use a standard 6-engine Starship, where that 10-ton payload is now limited to around 3,000 kilometers in range. One even more restrictive option is a 3-engine launch and using only one-third of a load of propellant. This option has a range of up to 1,200 kilometers, but these latter two options, at over 40 times the cost of an equivalent air freight journey, it becomes hard to see how they upset the status quo. My key takeaway from this section is that although these hops are technically possible, they only really make sense as part of a broader context. So I went back to thinking about full stack launches, Starship and Super Heavy, and realized there are still a number of variables to consider. You might be able to deliver a payload halfway around the planet in 45 minutes, but how do you unpack that payload and get it to customers? And how do you do that while being far enough away from a city to minimize disruption? You also need to make it cost effective by maximizing cargo throughput and maximizing the flight rate of the Super Heavy in particular. As it happens, for two of these things, you want to be closer to cities. And for the other two things, you want to be further away from cities. How to solve this riddle? If only there were some asymmetry in the system that's unique to rocketry that we could exploit. Well, what do we have to work with? We know SpaceX is working on Phobos and Deimos, two orbital launch platforms that are based on floating oil rigs. We know that putting these near highly populated areas is going to cause problems, especially since large coastal cities tend to have very busy ports. Even if the governments involved would allow them to be as close as 30 kilometers, we know from airport experience that the louder the disruption is, the less frequently it's allowed to occur, and the economics of Starship and Super Heavy mean that Super Heavy has to launch frequently. Now, some of you might be wondering, how loud can it really be? And the answer is pretty bloody loud. I mean, you can get a sense of this from comparing to other rockets that we have information for. Here's the end result of some work I did to put some bounds on the noise levels we would expect from Starship. Starting with the NASA environmental study baselined on the Antares 200 rocket, there are formulae that allow you to take the engine thrust of each of these rockets and from that extrapolate out the distances at which you would expect various sound levels. There's a bunch of numbers here, but I just draw your attention to the figures for Starship only launch or landing, which is about equivalent to Falcon 9. Super Heavy, of course, is well beyond anything flying today. And given how frequently it's meant to fly, I think the 46 kilometers shown there is probably a more reasonable minimum distance. One further complication is that these numbers are for A-weighted sound, or high frequency noise that gets attenuated by the atmosphere. Low frequency noise, like thunder or rocket engine noise, travels much further and has the potential to be a major factor in whether cities allow these rockets to launch nearby. All of this is bringing me to the main point of this video. There's an asymmetry here that we can take advantage of. What if there were two classes of launch platform? The first can be smaller, launch less frequently, and be built much closer to cities. These platforms would allow the Starship to use the three-engine 1200-kilometer hop profile that I discussed earlier, and by doing so would cause much less disruption and be able to reuse the drone ships that the Falcon 9 boosters currently land on. The second type of platform would be much bigger and based on the converted oil rig Phobos and Deimos platforms. They would be far away from cities and launch much more frequently. So how would it work? Well, you have a full stack launch from an orbital platform, which lands at a city platform to unload cargo. That Starship, now empty or with only 10 tons of cargo, performs a suborbital hop back to its local deep sea platform. At this point, it gets remounted on Super Heavy, loaded with cargo, and the process repeats again. The really nice thing about distinguishing between city platforms and deep sea orbital platforms is that you allow each to do what it's good at. Here's a picture showing how this concept might apply to the East Asian region. The inner circle here is just one of many patches of ocean around the world that are over 120 kilometers away from the nearest populated regions, and yet within a three-engine hop, 1200 kilometers, of well over 7 major cities. If, on the other hand, we assume we can do a 6-engine burn with a full tank of propellant, that then gives you a 3,000-kilometer range, meaning that a single orbital platform can service cities across a whole region of the globe. As you grow the system, you end up with what is still a relatively small number of orbital launch locations, but the starships launched from those locations and the cargo they carry can land at a much larger number of city platforms. It's in this context that I can see SpaceX deciding to build dedicated passenger shuttles, 9-engine starships that can take people quickly and directly from city platform to city platform. But in my mind, that's not how it starts out. So for the rest of this video, I'd like to show you one vision for an early stage of Starship point-to-point transport. I think it'll be just as it was in the early stages of aviation, where airmail was what funded the safety improvements that allowed passengers to travel by plane. Likewise, I think it'll be cargo transport as well as satellite deployments that drive the safety improvements required to make Starship point-to-point passenger transport a reality. Okay, let's get to the animations. Here you see one vision for a deep sea orbital launch platform which is based on the converted oil rigs like Phobos and Deimos. You have a launch tower with grabbing arms ready to catch Super Heavy as it returns from sending its Starship to orbit, and then place Super Heavy back on its launch mount. Before we go much further, I want to acknowledge that many of the 3D models you'll see in this video had to be finalized before October of 2021, meaning that they don't reflect the spectacular progress we've seen at Starbase in the last several months. Given the scope of this video, I felt it was a fool's game to try and keep up with SpaceX's rapid iteration. Instead, I'm going to focus on what each of the systems do, and then throw in a buffet of my own ideas to try and create an overview of how point-to-point transport might work. Let's start with a different concept for the landing legs on Starship. I think it's just so important that Starship can land anywhere on a flat surface, especially since the number of Starships will come to greatly exceed the number of Super Heavy boosters. It is still important to have these fold-out pins that I think Elon tweeted about some time back, and that allows the Starship to be picked up and mounted on Super Heavy with the same set of arms, but if it doesn't have to be caught by those pins, then they don't have to be anywhere near as substantial. Next up, we have the quick disconnect arms. So these are what transfer methane and oxygen to Super Heavy and Starship immediately before launch. The Super Heavy QD arm also has an additional role of steadying the whole structure during the mounting process. If you've been following SpaceX, this all hopefully looks somewhat familiar, but we know there has to be more to the story. In the Starship Payload user guide, we're told that payloads will be mounted within Starship at the launch site. The next part of this video is an attempt to imagine how that happens. In this example, I have the main platform connected to a secondary platform by a 1 kilometer long pontoon bridge. The bridge hosts a container transport tunnel as well as propellant lines, which are for transporting liquid methane and oxygen from this carrier ship. The secondary platform is also the base for a soundproofed control center, the helipads, and plenty of other functions that you don't want to keep on the main platform. The second ship you see there is what I conceive of as a floating distribution warehouse. So when a customer on the other side of the world decides they need a container of something quick smart, it's from here that those containers are loaded onto the next Starship to that city. If you've seen my previous videos on Starship, you know I'm a fan of Starship implementing a new container standard. Here are two variants on a concept standard I developed for this video. The container in front is open at the top, designed to carry and deploy small satellites like Starlink in orbit. Behind is a pressurized capsule designed to carry either cargo or crew. The first unique aspect of this container standard is that it's designed to fit onto an electric skate, much as in the early Boring Company videos like this one. The second unique aspect is this rotary frame, which allows the containers to be gripped both by the cranes which load and unload Starship, but also by a mechanism within Starship itself. This allows the containers to be kept in the right orientation throughout all phases of the Starship flight profile, which is obviously even more important once you have actual passengers boarding Starship. And I really do think you want the boarding process to take place on a secondary platform at a safe distance like this. You want everything to be packed up and ready to go so that loading cargo takes no longer than loading propellant. Okay, so all your containers travel down the tunnel on this pontoon bridge on the electric skates, arriving at this small chamber underneath the platform. It's at this point that the container gets separated from the electric skate because the container crane grabs onto two of the three contact points on the rotating frame there, and this is how the container begins its journey up the tower. Let's pause for a moment and list out the four sets of arms that are on this tower. The first of those being the gripping arms to catch the Super Heavy as it comes into landing. The second is the cargo container arm, which puts the cargo into Starship. The third are the quick disconnect arms, which transfer liquid methane and oxygen to Super Heavy and Starship. And lastly, we have a set of payload bay door arms, which are there to open Starship's payload bay so that cargo can be loaded and unloaded whilst it's on the platform. As we go through this next little section, I want you to bear in mind that we're not trying to fill up the whole volume of the payload bay, which is huge. Instead, we're trying to get at least that 100 tons of cargo and load it as quickly and autonomously as possible. The basic idea here is to have a system that doesn't require people on site to manually guide it. Instead, you want to have the rotating frame on the container that latches onto the mechanism inside the Starship payload bay, and have it so that these two systems work together to both hold the containers securely as well as keep their orientations constant, facing upward and outward towards the gap where the payload bay doors open. This becomes especially important once it's time to load passengers. So, imagine you've got a ticket and you're one of 8 people in this passenger capsule. I'll make the capsule transparent for a moment here because I want to show how the acceleration couch that you'd be sitting in has to rotate through some angle so that the passengers are comfortable at all stages of the flight, during launch, during re-entry, descent and landing, and also when you're transiting to and from the platforms. I do hope it's becoming obvious by this stage in the video that having a container standard like this enables this Starship to be a multi-purpose vehicle. having small satellite deployer modules, pressurized cargo modules, and dedicated crew modules enables a variety of different flight profiles. The first type is this fast point-to-point transport that takes place in 2 to 3 hours, and the second type is for low Earth orbit satellite deployment, such as they might want to do for the Starlink constellation. And this applies especially once Starlink satellites need to start being replaced, and there's no need to launch hundreds of Starlink satellites at a time. What the container standard gives you is flexibility to mix and match your payloads on any given trip. Whether it's the fast point-to-point transport mission or a low Earth orbit satellite deployment, it's now relatively simple to add as many crew modules to this mission as there are people who want to pay to go. The third option, which I'm going to animate next because I think it adds a fun extra dimension to the point-to-point system, is a visit to a transfer space station. Okay, so you've still got your ticket, you're in this crew capsule, and you're along for the ride on a mission to deploy Starlink satellites. Unlike with the fast transit option, with this version you get to have the payload bay doors open so you can see the Earth from space, and you also get hours or days to experience microgravity. There may be no particular need to have people along to watch Starlink satellites get deployed, but in principle, this is no different from a rideshare flight, except some of the payloads are people. But what if you did want to go visit a space station? Well, here's one potential evolution of this capsule design to make it more like a Dragon 2. That is, with propulsion and a docking adapter that would enable it to attach to any space station. I'm well aware this adds complication to the mission profile, but there is one cool thing that doing this would allow, and that is to use a space station or a Starship as a transfer station. So, what do I mean by that? Well, here is an example of a 2-week timetable showing arrivals and departures of starships from various locations on Earth. Across the top, in the header row, are the 7 deep sea orbital launch platform locations that I showed earlier in the video. Each group of 3 colors indicates a flight by a single starship, with liftoff from that platform on the day in green, and then landing at the city platform of the city in the orange square. Why would you do it this way? Well, in the early days, when prices are still quite high and the number of people that can do this are still quite low, this means you don't even have to find 8 people who want to go from one city directly to another. Instead, you just have people go to the transfer station, stay there for a while as they'll want to, and then leave on the starship which is going to the city where they want to end up, which could be in the same country where they started from. Not only would this be the coolest transit lounge in existence, it would also help drive the development of all the technologies you need to have many people in space at one time. And if you ask me, the number of people in space is probably a better indicator of whether we're becoming a spacefaring civilization than where they are in space. And with that lofty goal in mind, let's come back to Earth and have a look at a city platform. So, we've been through the blistering heat of re-entry, and our Starship is now in that roughly 3-minute skydiver phase as it falls towards the Rio de Janeiro city platform. If you remember from earlier, we want the city platform to be at least 11 kilometers out to sea so as to not disturb the city or shipping traffic. In this case, I'm imagining a combination of tunnel and pontoon bridge will allow containers taken off Starship to be transported directly into the city. Here we see Starship landing safely on its landing legs on the same drone ships that the Falcon 9 boosters land on. The assumption is that there are going to be many more of these city platforms than there are orbital launch platforms. So it makes sense that you would want to reuse these drone ships, which are only listed online as low hundreds of thousands of dollars each, as opposed to the Phobos and Deimos style oil rig platforms, which are upwards of $30 million to produce. Here, we have a pair of arms that are designed to steady the drone ship while the payloads are being unloaded, And as before, we have a quick disconnect arm for transferring propellant and payload bay door arms. But notice how, in the absence of the super heavy grabbing arms or the super heavy launch mount, the whole service component of this city platform can be much smaller than the orbital launch platform, while still replicating many of the same systems from that orbital launch platform. The aim, of course, is to make this whole system fast and easily automatable. By separating the city platform into service and drone ship components, it means that cities will be able to store as many or as few starships as is needed, and it also means that starships on those separate drone ships can be brought into port in cases where weather is not so good. You also have the advantage of the flexibility from a logistics perspective, where if for some reason the floating distribution warehouse at the orbital platform doesn't have a particular piece of cargo, it can be transported from the city out to the city platform on an electric skate, loaded onto Starship, and then be part of its 10 tons of cargo as it hops to the orbital platform. With this final set of animations, I just want to highlight a safety option that this system makes possible. Most of you will be aware that there are a variety of launch escape systems which are there to rescue the crew in case of a booster anomaly. Starship's emphasis on full reusability means we won't see anything quite like this, but that doesn't mean that the same principles don't apply. Having crew or precious cargo in a separatable capsule gives you options when you're doing things that push the envelope. And I'm sure we all agree that nothing pushes the envelope quite like Starship's landing swoop maneuver. And I don't know about you, but I'm going to be holding my breath every time Starship does this for quite some time to come. The process here is that after the burning heat of re-entry and after Starship is below the speed of sound, an engine check would be performed. If any critical issues are identified, you still have this 3-minute skydiver period to blow the hatches and rescue the passengers and/or precious cargo. The way this works is that each capsule has an emergency parachute, and just as during cargo loading or unloading, the rotary frame within Starship rotates to position each capsule where it needs to be so it can deploy a parachute and be pulled free of the Starship. Lastly, I'd just note that even without the payload bay doors, Starship should still have enough structural integrity to successfully complete a landing if the engines are working, meaning that this landing escape system, while incredibly inconvenient if used in error, shouldn't prevent further reuse of the vessel after refurbishment. Back in the beginning of this video, I argued that SpaceX's success in implementing a point-to-point transport system with Starship would depend on whether they addressed these three factors: safety, cost, and context. I hope you'll agree that the concepts I showed you in the rest of the video try to do this. To improve the overall safety rating of the system, I suggested that SpaceX focus on high-volume point-to-point cargo flights, these being basically a faster version of what shipping and air freight already does. Having a standard container system, which can be loaded or boarded at this secondary viewing platform, means that people and cargo are kept out of the danger zone for as long as possible. Also, by making your passenger capsules a direct analog of Dragon 2, it means you get the safety improvements associated with basing your life support systems and your parachute systems on existing systems with space heritage. Likewise, the landing escape system is based on concepts that already exist, and will provide a contingency system for as long as it takes to get Starship propulsive landing up to the necessary safety rating. When it comes to cost, all of my ideas were around how to facilitate the high volume cargo transport that will pay for all this, while also making most cost effective use of the different systems. The best way I can think of to do this is to have multiple lower cost city platforms, all grouped around and within hopping distance of a single orbital launch platform. This way, Super Heavy gets to fly very frequently, launching lots of different starships that are fed to it from the surrounding city platforms. The cargo that launches on those starships is kept at that floating distribution warehouse, which is co-located with the orbital platform. This is how I think we can get that fast cargo transport, achieving those 2 to 3 hour delivery times to the customers in the cities where they're located. This system starts to look like the backbone of a network of launch platforms, the kind of thing SpaceX is going to need to achieve their larger goals. Now, while Starship's cargo capacity is vast compared to the global launch industry, it's tiny compared to global cargo transport. In fact, a daily launch of Starship would only be equivalent to 0.06% of global air freight. I think it's not much of a stretch to suggest that many multiples of this, maybe 1% of global air freight, would be willing to pay more to go faster. If, on top of this, Starship is designed so it can mix and match its payloads, I don't think it's too much of a stretch to imagine that on some fast cargo trips, there will be enough people to fill a passenger capsule to take the journey with that cargo, just as people in the old days used to take a plane journey with the mail. Probably what I think is the most important idea in this video is that there is an asymmetry between the noise and disruption caused by the full stack Starship, so Starship together with Super Heavy, versus the noise and disruption caused by Starship alone when it lands. And I think that leads us inevitably to the need for two different types of platforms: more numerous, low-cost city platforms which are closer to the city they serve and are less noisy, less disruptive, and this is in contrast to the deep-sea orbital locations, which can launch as frequently as necessary. As I'm sure you can tell by now, this video became a passion project for me, a story that definitely grew in the telling. My aim was to show you one vision for how Starship point-to-point transport could work, but I'm as curious as anyone to see how SpaceX actually does it. If I was to narrow the results of this project down to 3 ideas that I would be stoked to see SpaceX take into account, it's these. Firstly, the idea of a multi-purpose variant of Starship that is focused on fast cargo transport in addition to satellite deployment. This is how I think they achieve the flight numbers necessary to ensure safe passenger transport. Secondly, while having a two-step point-to-point transport system does add 40% to the cost of each flight, I think this is the best way to address the safety, cost, and context factors I highlighted earlier. And lastly, because the system design allows cities to gain the benefits of fast cargo transport without the disruption that would be caused by super heavies launching nearby, it means that cities around the world can be a part of building this network of launch platforms. And that will start a virtuous cycle that can only help SpaceX achieve their larger goal, making humanity a spacefaring civilization. As we round up, I want to remind you that we have on our website our Space Payload User Survey. This is for people who are part of the space industry, and especially if you've sent a payload to the International Space Station. Our aim with this survey is to better understand the needs of our potential future customers, people who would have use for a free-flying space centrifuge that we call Carousel Space Lab. Lastly, if you like this video and you want to support a West Australian startup company like us, I remind you again that we have this PayPal Pay Me link, and you have my sincere thanks for your contribution.